Hello, good evening to all of you. I am Sivanand Nadagatti, K-Set class lecturer. You know already, as we start the linear algebra, in that we going to discuss the triangular matrix. Okay, triangular matrix, and it has two types are there. First one is the upper triangular matrix, and second one is the lower triangular matrix. Okay, then in upper triangular matrix, how to define the upper triangular matrix? First one, see the upper triangular matrix. Definition: a square matrix A is equal to AIC is said to be an upper triangular matrix if the condition on the entries of the elements, okay, another note really condition that is equal to Aij is equal to 0 if I greater than G, for all I greater than G. Okay, then Aij equal to 0 for all I greater than 0. It is a definition of the upper triangular matrix. Okay, hingandre in Aij equal to 0 for all I greater than 0. This implies that if you take the square matrix of order n, the entries of these matrix are here A11, A12, okay, then A13, and so on, A1n. It is first row of the matrix. Then here 2 1 is there. Okay, A21 is 0 because here I is equal to 2, J is equal to 1. Obviously, I is greater than J. Therefore, A21 element is 0. Again, A22 as it is, no change. A23 is keep as it is, and so on, A2n. Again, in third row, A31 is 0, A32 is 0, A33 keep as it is, no change, and so on up to the A3n. If you observe all the elements of the diagonal lines, all the elements which are below the diagonal elements, their condition is I greater than 0. Okay, that's why these elements are 0. Okay, then up to the ANN. Okay, andre yav matrix olaga the elements which are below the diagonal elements are 0, and that matrix is called in the upper triangular matrix. Okay, ಅದಕ್ಕೆ ಏನು ಕರಿತೀರಿ upper triangular matrix ಅಂತ ಕರಿತೀರಿ. Okay, the general n by n upper triangular matrix is there. Then as you consider the vector space of set of all the matrices, ಹೌದಾ, ಏನು ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ P ಏನಾದ್ರೆ ಇಲ್ಲಿ P is an mn of C. Okay, it is a vector space. Okay, ಏನಾದ್ರೆ ಇದು it is a set of all the matrices. A is equal to Aij such that Aij are in C complex matrix. Okay, over the field C. Field ಏನಾದ್ರೆ ಇಲ್ಲಿ is also C. Then you know it is forms an vector space. The Mn of C is vector space over the field C. ಹೌದಾ, ಇದೇನಾಗ್ತದೆ over the field C ತಯಾರಾಗ್ತದೆ. Complex matrix over the field C. It is forms an vector space. As you know, its dimension is the dimensions of mn of c in bartadri, that is equal to n square. Okay, but if you take a subset w, which is defined as set of all the square matrix of aij, such that aij is equal to 0 for all I greater than j. Okay, another here this condition is for the upper triangular matrix. Okay, iದೇನಾಗ್ತದೆ W is a forms and subspace. That time our what is our aim? Next our aim is it is a subset. ಹೌದಾ ಏನಾಯ್ತು ಒಂದು subset of V ಆಯ್ತು because it is set of all the upper triangular matrices. Then if you take two upper triangular matrix A and B is belongs to W, okay, is belongs to W, then A plus B is also belongs to W. Okay, andre ಏನ್ರಿ sum of two upper triangular matrix is upper triangular matrix. Okay, ಹಂಗೆ ನೀವು ಇದು ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ if A is equal to aij ತಗೋರಿ, then B is equal to bij ತಗೋರಿ. Okay, then you define the C matrix that is A plus B. Then that is denoted by that matrix is denoted by Bij. Sorry, it is Cij. And where each elements nodri Cij hand depend ಮಾಡ್ತೀರಿ Cij is equal to the Aij plus Bij. And for I greater than 0, for I greater than 0, then Cij is equal to 0 plus 0. For I greater than 0, Aij 0, Bij 0, therefore it is also 0. Okay, then it is true for all the I greater than J. This implies that in Cij, okay, the matrix C is also upper triangular. A plus B is belongs to W. Okay, ಇದೆಲ್ಲ ಐತ್ರಿ ಇಲ್ಲಿ W ದಾಗ ಹೋಯ್ತು. Okay, therefore the sum of two upper triangular matrix is an upper triangular matrix. And second condition of the subspace in ಮಾಡ್ತೀರಿ for any scalar alpha belongs to the C. Okay, then is it alpha A is belongs to W? Okay, nodri. Okay, if A is upper triangular matrix, then alpha A is also upper triangular matrix. Okay, this implies that these two conditions combining a linear combination of upper triangular matrix is an upper triangular matrix. ಏನು ಹೇಳಬಹುದು ನಾವು ಇಲ್ಲಿ the linear alpha A plus B is belongs to the W. Okay, this for all A and B belongs to W, then alpha belongs to the field. Okay, this implies then W is subspace of W is subspace of Mn of R. Mn of R. Okay, I hope all of you can understand this concept. Then here you know the dimension of Mn of R is another really dimensions of Mn of C is n square. Then what is the dimensions of W? Okay, ಏನು ಬರ್ಬೋದು ನೋಡ್ರಿ. What is the dimensions of subspace W? Okay, then here the dimensions of subspace W is equal to the number of non-trivial entries in upper triangular matrix. ಹೌದಾ ಹೆಂಗ್ ಮಾಡ್ತೀರಿ ಇಲ್ಲಿ number of non-trivial entries. If you take any upper triangular matrix, ಯಾವ್ದು ಬೇಕು go to the upper triangular matrix ತಗೋರಿ. Okay, then that is equal to the ಇಲ್ಲಿ ಏನ್ ಬರ್ತೀನಿ ಎಲಿಮೆಂಟ್ಸ್ ಇಲ್ಲಿ upper triangular matrix ಇಲ್ಲಿ ಸ್ಟಾರ್ ಬರೀತೀನಿ ರೀ. First rows elements are all star. Then second element is 0. Then principal diagonal elements are all still non-arbitrary non-zero entries are there. 0, and here is also star belongs to star. So on in the last row, it is only last element is star, remaining all the elements are 0. Okay, then here star indicates non-zero arbitrary constants. Star ಏನದು ನಾನ್ ಟ್ರಿವಿಯಲ್ ಎಂಟ್ರೀಸ್ ಕ್ಯಾನ್ ಕರಿತೀರಿ ನಾನ್ ಟ್ರಿವಿಯಲ್ ಎಂಟ್ರಿ ಕರಿಸ್ತೀವಿ ನಾನ್ ಟ್ರಿವಿಯಲ್ ಎಂಟ್ರಿ. Okay, then if you want to write any n by n upper triangular matrix, then how many non-trivial entries you require? Especially, how many stars are there here? In the first row, there are n stars are there. In second row, n minus 1, because first element is 0. In third row, first two elements are 0, remaining n minus 2 elements are star. And so on in the last row, n minus 1 elements are 0 and only one element is star. Okay, then here how many stars are there? Estadori non-zero non-trivial entries here. The number of non-trivial entries is equal to, in first row n, in second row n minus 1, in third row n minus 2, and so on up to 2 plus 1. Okay, then what is this? This is the first row. It is sum of first n natural numbers. Okay, another idu, it is sum of first n natural number, that is given by the formula n into n plus 1 divided by 2. Okay, then it is the number of non-trivial entries in upper triangular matrix. Okay, then what is the dimension of W? Dimensions of W is equal to number of non-trivial entries. Okay, non-trivial entries. That is equal to the n into n plus 1 divided by 2. That is the dimensions of set of all the upper triangular matrix of order n. ಹೌದಾ, ಇಲ್ಲಿ ನೀವು ಇದು ಇದೇ ಎಲ್ಲಿ ಬರ್ತದ್ರಿ, ಹಿಂಗೆ ನೀವು ತಗೊಂಡ್ರೆ set of all the ನೀವು W